In 2019, a team of wildlife scientists stood on the bank of a river in British Columbia. The water was still, completely still. No fish, no birds, no sound, except the wind moving through dead reeds. The river had been silent for almost 2 decades. Whatever had once lived there was gone, and most experts had already written it off. They called it ecologically dead, a river with no future, but one man disagreed. He had a plan that almost nobody believed in. He wanted to release 12 river otters into that lifeless water. Not dozens, not hundreds, 12. His colleagues thought he was wasting government money. Some called it reckless. One senior biologist told him directly, "You're putting animals into a grave." But he pushed forward anyway. The otters were released on a cold Thursday morning in October. No cameras, no press, no announcement, just 12 animals slipping quietly into dark water. What happened over the next 18 months would shock the entire scientific community, not because the otters survived, but because of what they built. Deep in that river, hidden under the surface, something that no one predicted, something that changed the entire landscape. And it all started with branches. His name was Dr. Marcus Hale, a wildlife ecologist based out of Vancouver. He had spent over 15 years studying river ecosystems across Western Canada. And in all that time, he had never seen anything quite like the Skeena tributary in northern British Columbia, a river that had simply stopped living. It didn't happen overnight. It started in the early 2000s, when a paper mill upstream began dumping chemical runoff directly into the water. The pH levels dropped, the oxygen levels collapsed. Within 3 years, the salmon were gone. Then the insects, then the birds that fed on them, then everything else. By 2008, government surveys confirmed what local fishermen already knew. The river was functionally dead. Cleanup efforts began. The mill was eventually shut down and fined. The water quality slowly improved over the following decade. But the ecosystem never came back, because cleaning water is one thing. Rebuilding an ecosystem is something else entirely. That's what Marcus understood that others didn't. He had been studying a concept called keystone species recovery, the idea that certain animals, when reintroduced into the right environment, don't just survive. They rebuild entire food chains around themselves. And he believed the North American river otter was exactly that kind of animal. But there was a problem. River otters don't just need clean water. They need structure, shelter, slow pools, specific water depths, and the Skeena tributary had none of that anymore. The banks were eroded, the flow was too fast, the riverbed was bare gravel. Even Marcus had to admit, the conditions weren't right. But then, something unexpected happened during a routine survey. Something that changed everything. Something small, something built from branches. It was a beaver dam, small, barely 3 feet wide, tucked into a bend in the river where the current slowed near a cluster of dead alders. Marcus almost missed it, but when he crouched down and looked closer, he realized what he was seeing. The dam had created a shallow pool behind it. Calm water, collected sediment, a thin layer of algae already forming on the rocks. Life, tiny and fragile, but life. Marcus stood up and looked at his field assistant, a young researcher named Daniel Forsyth. Neither of them said anything for a moment, because they both understood what this meant. If a single beaver had accidentally created the right conditions for recovery, what would happen if those conditions were deliberately expanded? Marcus went back to his office and spent 3 weeks building a proposal. He calculated the number of otters needed to make an impact without overwhelming the fragile system. He studied water flow data, sediment reports, and historical fish population records from the 1990s. He contacted the Canadian Wildlife Service. He contacted the British Columbia Ministry of Environment, and after months of reviews, budget debates, and risk assessments, he was approved. 12 river otters, captured humanely from stable populations in Alberta, relocated, tagged, released. The government gave him 18 months to show measurable results. If nothing changed, the program would be cancelled. No extensions, no second chances. Marcus accepted the terms. He was confident. But what he didn't know, what nobody on his team had accounted for, was that the otters wouldn't behave the way the models predicted. Not even close. The first 2 months were discouraging. The otters moved through the river but didn't settle. They explored, they dove, they disappeared for days at a time. Marcus and Daniel tracked them through GPS collar data every morning. The signals were scattered across nearly 12 kilometers of river. No clustering, no patterns, just 12 animals wandering through a broken landscape. By week 9, one of the otters had left the study zone entirely. The government liaison assigned to the project, a senior officer named Robert Callum, called Marcus directly. The conversation was short and not friendly. Marcus had 9 months left, but then, in the 10th week, something shifted. The GPS data started changing. 3 otters began returning to the same stretch of river, near the old beaver dam. Then 4, then 7. Marcus and Daniel drove out before sunrise one morning and set up observation equipment on the ridge above the riverbank. And what they watched over the next 6 hours, they had never seen before. The otters weren't just hunting. They were working, moving branches, piling debris against the dam structure, redirecting small channels of water with their bodies and their claws. They weren't building like beavers build. It was more instinctive than that. Less precise, but the result was the same. The pool behind the dam was growing. Slower water, deeper pockets, more sediment collecting at the bottom. Marcus pulled out his water testing kit and dipped it into the expanding pool. The oxygen level reading made him go completely silent. Daniel looked over his shoulder at the number, then looked at Marcus. "That's not possible," he said quietly. But it was, and it was only the beginning. The oxygen reading was 4 milligrams per liter. That doesn't sound dramatic, but for context, when Marcus first surveyed this river 4 years ago, the reading was 2.1. Anything below 3 is considered a dead zone for most aquatic life. 8.4 was healthy. 8.4 was the kind of number you find in a thriving mountain stream, not in a river that had been written off as ecologically finished. Marcus sent the data to 3 independent labs for verification. All 3 came back with the same result. The otters had fundamentally changed the water chemistry, not through any single dramatic action, but through weeks of small, consistent behavior. By expanding the beaver dam structure, they had slowed the water flow across nearly 400 meters of river. Slower water holds more oxygen. Slower water allows sediment to settle. Settled sediment becomes riverbed. Riverbed becomes habitat, and habitat attracts life. Within weeks of the oxygen shift, aquatic insects began appearing in the sediment samples. Stoneflies, mayfly larvae, small freshwater shrimp, the base of the food chain, rebuilding itself from nothing. Robert Callum flew in from Ottawa to see it personally. He walked the riverbank with Marcus for 2 hours without saying much. At the end of the walk, he stopped and looked out over the expanding pool. He approved an additional research grant on the spot. But Marcus wasn't celebrating, because the GPS data that morning had shown something he couldn't explain. 4 of the otters had moved upstream. Far upstream, beyond the study zone, beyond the mapped area, into a stretch of the river that hadn't been surveyed in over a decade. And when Daniel followed their trail the next morning, he found something that made his hands go cold. Daniel had followed the GPS signal for almost 3 kilometers upstream. The terrain was rough, dense brush, uneven ground. But when he pushed through the last wall of vegetation and reached the riverbank, he stopped completely. In front of him was a second dam, not built by beavers, built by the otters, larger than the first, more complex, branches woven together with river grass and packed mud. It stretched nearly 6 meters across a narrow bend in the river. Behind it, another expanding pool, calm, deep, already showing signs of sediment buildup. The otters hadn't just modified an existing structure, they had constructed a new one entirely on their own. In a location they had chosen themselves. Daniel photographed everything and called Marcus immediately. The scientific paper they published 8 months later caused significant debate in ecological circles, not because anyone doubted the data, but because the behavior itself was almost unprecedented for the species. River otters had never been documented engaging in deliberate dam construction. They had never been observed selecting and relocating structural materials with this level of consistency. What those 12 animals did in that river forced researchers to rethink what they understood about otter intelligence and instinct. By the end of the 18-month program, salmon had returned to the lower stretch of the river for the first time in 19 years. A river that scientists had declared dead was alive again. And it happened because one man believed 12 animals could do what years of human intervention couldn't. Sometimes nature doesn't need us to fix things. It just needs us to get out of the way. If stories like this make you think differently about the world, you're exactly who this channel is made for. Hit subscribe because what we're covering next, you won't want to miss.